This is the story of two engineers. They shared quite a lot of knowledge, including, it would appear, sunglass suppliers. But we have Bob Trigg from Norton, or Norton Villiers Triumph. He went on to work for Yamaha, and we have Masao Furusawa, who was what's called a modal engineer, vibration engineer, working for Yamaha. So first, let's just run through a couple of things that really matter when it comes to motorbike racing. This is Caroline coming around the corner at the bottom of the road on a little Suzuki 125 when she was learning to ride. That bike's got a wheelbase of about 56 inches, 55, 56 inches. Its rake is about 27 degrees, trails about 100 millimeters. Here's Stefan Bradl, different corner, slightly more committed. Wheelbase about 56 inches, rakes about 27 degrees, trails about 100 mil. In simple numbers terms, there's not a million miles difference between the two bikes. Maybe an inch here, maybe an inch there. But on the race bike, there's an awful lot of forces being generated. When you think of a motorcycle, you mustn't think of a two-wheeled car. You've got to think of an aircraft where somebody's sawn the wings off and shoved a couple of wheels underneath, because we're flying on the ground. And when you're banked over on a plane at 60 degrees, two gravities are trying to rip the wings off. Well, on a motorcycle at 60 degrees, two gravities are compressing the suspension, forcing the tires into the track, and if you get it wrong, making it slide. But you've got to deal with those pressures. So as the bike works, it's more like an aircraft than any form of four-wheeled vehicle. To deal with that, we've got to control things very, very gently. So what matters is that when you open the throttle, 1 degree, you get 5 horsepower or 4 horsepower. You do not get 10. If you get 10, you go to hospital. So the low speed, low throttle control on a motorcycle is way more important than the peak horsepower. It just must be completely and utterly controllable. Yamaha, at the start of Moto GP, were not successful. They discovered that the V5 of Honda made more power, but more importantly, it could go around corners better, it could accelerate better. It seemed to have more grip, and they couldn't understand why. Then Furusawa turned up, and he had several very, very good engineers working for him. One was a chap called Kyoichi Tsuji. Tsuji had been Yamaha's man in Formula One. He'd lived in Rugby in the middle of, well, just down the road from Birmingham in the UK, building Formula One engines with Yamaha badges on in a company called Judd. But he understood a thing called inertia torque. Now, inertia torque is the pulses that get put into the power delivery by the crankshaft speeding up and slowing down. When the piston goes down on a 4-cylinder engine, 3 pistons are being pushed, 1 is doing the pushing. But actually, going down and going up, the piston slows down. At the top, where it's not trying to move up and down that much, it speeds up. So a crank is going slow, fast, slow. And that pulsing could mess up the way you generate grip. So on a 180-degree crank, you've got this sort of arrangement. The black lines are the combustions, but the bigger pulses are the shake that's put into the power delivery by the speeding up and slowing down of the crankshaft. If, however, you move the crank pins so they're at 90 degrees, 2 pistons are trying to speed up where 2 are trying to slow down. You have to beef up the crankshaft if you do this. Yamaha, on their road bikes, increased the main bearing journals by 4 millimeters to stop the crank from being ripped apart. But it means the power that's going down to the tire is smooth, and the only pulses that are going through are the power pulses. So it's a bit like some form of space hopper. Now, who here remembers space hoppers from their childhood? those big balloons used to bounce along on. And picture one here is a conventional 180 crank, and those are the individual bangs. This is on about 100-mile-an-hour tire in 6th gear. The next one is what we call big bang, 2 bangs together. Both of those mess up the tire grip. And then the last one is what Yamaha ended up with, which is this progressive push, 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 but very smooth the rest of the time. That, in terms of power delivery, gave Yamaha an inline-4 engine that had all the advantages of a V4 and none of the disadvantages of trying to package 2 sets of cylinders. So, this is the state-of-the-art 2006 Yamaha Moto GP engine. If we were to see a photograph of their very latest motor, it looks almost identical. Since then, they've done 990 down to 800. They look pretty much the same. All the shafts are in the same places. It's just the combustion chambers and valve timing that's really different. Pneumatic valves on the later ones. The latest 1000cc engine also looks the same. So it's a crankshaft, it rotates backwards. If you look on the back of the engine there, there's a series of gears in a casing going up the middle of the back of the engine. Makes it narrow, makes all the right sort of power. But that's an engine that's got a cross-plane crank, this 90-degree crank facing, deliberately designed in. And if we start looking back, we can start trying to work out where that came from. The earliest one I can find, and I'm absolutely sure there'll be somebody here who will tell me there's something earlier, is an MV from 1966, 500 triple, where they had a 120-degree crank. Now, 120-degree cranks aren't quite as good as 90, but still the power is a lot smoother than a stop-and-go 180. So this engine was actually remarkably smooth down at the tire contact patch. Then in the early 70s, a company called URS built a sidecar engine, a 500. If you look very carefully, you can see it's got inlets going through between the cams and behind. Really sophisticated motor. This is in a Sealy chassis. It wasn't particularly successful as a solo bike. But it had all the advantages of cross-plane. Then if we look, we try and find the first road bike that's like this. And it's a Triumph Trident that I'm aware of. I'm not aware of anything other than that. I believe Moto Guzzi made a triple back in the 30s, but they only made about 6 of them. So I've kind of decided to discount that. And there's nobody here I can ask what sort of crank it had. But this bike was, by definition, cross-plane. And it was a hidden advantage that the Triumph triples had, and the BSA triples had, insofar as it was good for tire life, it was good for on-edge grip, and it was good for drive. BSA and Triumph went racing. These 2 gentlemen were right at the forefront of that. This is Paul Smart, who was Triumph's lead rider in the late 60s. He rode a triple, and that's Rob North. He designed the chassis. And this is actually an AMA event back in 2005, I think. Chassis-wise as well, at the same time, Norton was building some fairly special chassis. This is Peter Williams, and this is one of a limited number of recreations of what people call the monocoque Norton. If you look at it, I would like to suggest that actually it's far from being a monocoque. It's a twin-beam chassis that just happens to have fuel tanks on the outside. And to my mind, that's the first of the modern world's beam chassis racing bikes. This line, what I call a hobby horse line, you can also call it the rear trail line, or you can call it the neutral line. But basically, it is that line that the motorbike turns on. If you want to turn right, you turn the handlebars on a motorcycle to the left. And you drive the front wheel out from underneath the bike. So the front wheel goes that way, and the motorbike falls over. And it falls over on that line. If you really want to make life easy for yourself, you put all the weight on that line. Because if it's on that line, you're not lifting it, you're not lowering it, you're just rotating it. So engines that lean forward to about 45 degrees have an advantage. They can be on that line. If I go and find a picture of a Ducati Moto GP bike, and I put a line starting in the middle of the rear tire, and the top about where I reckon the lower bearing is, usually I find I've gone straight through the end of the crankshaft. So they put the major mass on that line, and that makes a big difference. Now, when you look at where a bike has to be stiff, you can then work out where it doesn't have to be stiff. And for racing, we need to use that technology, we need to use that knowledge to try and help our tires last a bit longer. So if you look at the bike on the other side, you've got several lines running through it. The red line is basically the neutral line, the hobby horse line. And the levers you can see below are where the wheel is trying to twist that chassis when it's leaned over. And we want the bike to twist on that line, but only a very limited amount, because our tires, in the end, are just a pair of balloons. If we crush them, we destroy the rubber. If we don't crush them at all, they haven't got a big enough contact patch. So you've got to find the point where you've flattened the tire enough to get grip, but not so much as you wipe out the rubber. And that, in MotoGP terms, is the game with chassis. Finding the right weight on each end, and then finding the right flex to get the tires to wear at the right rate is absolutely critical. And it's very, very difficult, because it's very difficult to ask a tire what it wants. The only way you can do it is you build a bike, you put the rider on, and you go ride around a racetrack and you see how you get on. And preferably, you've got the ability to change stuff quite quickly, if necessary. So, we've got Yamaha now in knowledge of where you want some rigidity. You've got a reason for that. You've got the tire, you've got the knowledge of how to keep the engine power nice and smooth. And then we sit down and look out, okay, we've worked out where the engine was smooth. Where was that chassis design? When did people start putting pieces of metal in the right places? Now, this is a wooden chassis, but the beam, I would argue, is in exactly the right place. It's strong where it needs to be strong. I don't think at this point anybody was worrying about crushing rubber tires. They look remarkably metallic to me. Then you go and you have a look around the records, and a chap called Rex McCandless, an Irishman, put together this chassis. It's a Triumph Twin, but he's deliberately leaned it forward, so it's following the rear trail line, and it's got a beam, and you can see the beam going down through the bike. It was so successful, he was hired by Norton to decide them a chassis. And that's where it all went a bit wrong, because if you look up in the top corner, you can see what Norton ended up with, which was called the featherbed, which is a bit of a shame, because that chassis was nowhere near as good as the one he started with, but clearly Norton had some ideas of what a motorbike should look like and weren't listening to the physics and the logic behind the design. Then you start going through. Now, this is a mostly British history. I'm sure there are other makes internationally that were doing similar things. But in the mid-50s, BSA made this experimental 250 single. It never raced. They just ran out of nerve. But it had a chassis, and you can see it's got a beam going from just under the handlebars down to the swing arm in a nice loop. One of the engineers on that was a chap called Doug Heel. Doug Heel ended up on the Triumph Triple project, and he helped Rob North design the 500 Twin on the other side. Same line, same beam, same structure on the rigid part of the chassis. And this is a proper Rob North Triple. Again, this is a recreation. This was at AMA Vintage Days back in 2006. But you can see clearly where he's put the strength and what matters to how the bike works. It's also interesting that this is a BSA engine with the tilted forward angle. Now, in the mid to late 70s, Kenny Roberts and Yamaha were starting to look at doing some Grand Prix racing. Yamaha wanted to send Roberts to Europe. They thought he could beat the Suzukis, and they wanted to give him a bit of help. So in addition to a 500, he got given a 250 so he could do some more practice laps. And the bike they built for him was built in the USA, TZ250 engine, but they hired Rob North to build a monoshock version of his Triumph and BSA chassis for Kenny to ride. Now this thing was called the Mighty Tiny TZ. I believe there's one here. There's only 6 made. I think the museum's got one of them. And you can see that Rob built it exactly the same way as his Triumph Triple. And he put the headstock through to the swing arm pivot beam in to keep it rigid in the right places. At about the same time, motorcycle styling was changing. BSA Triumph were convinced that their designs were far too fuddy-duddy. They needed something that would appeal more to the youth. And they hired a young man called Craig Vetter to design the motorcycle. You've got a few of his final bikes out here, mystery ships, which were, as far as he took stuff. But this is a Triumph Hurricane, really elegant styling. But he didn't do just one bike for them, he did 2 bikes. The second bike, Norton were also doing some different styling at that time. This is their first version of the Commando, and it was a fastback, and they started to put a tail on, other things like that. Bob Trigg, who we mentioned at the beginning, who went on to work for Yamaha, at that time was working for Norton, and he helped design the rubber mounts that allow the Norton engine to be smooth, isolastic. That's what Furusawa was talking about when he told me that's where his career had started. Bob Trigg helped design one of the other bikes in the range, but again, the British were starting to at least acknowledge they needed to do something. This is the second bike that Vetter designed for Norton and Triumph. It's the Bonneville TT, and you can see it's got a very distinct teardrop tank, a very distinct instrument binnacle pointing back at the rider, and it was designed to look like a TT bike over here. This is my personal Triumph. Also bought at that AMA Vintage Days, but we won't go into the cost of that. That all got a bit silly. When this bike was designed, Bob Trigg was in charge of the technical side of Norton Villiers Triumph. So he'd done isolastic. He'd ended up putting electric start on the Norton Commando, the Mark III, and he ended up building the T160, again with electric start. Way too late, the British were waking up. Norton Villiers Triumph effectively went out of business late 76, early 77. But a small group of people, including their design group, went to a separate facility, and they basically worked out that they could be designers for hire. One of their contacts was with Yamaha, and they ended up being told to build a restyle job on what was the RD400. Now, the most normal RD400 is a very boxy design, and this was a modification of that design. I don't think they did anything structural to the bike, but just the shapes and everything were put together by the Norton Villiers Triumph design team, led by Trigg. And you can see, I think, if we flick back again, that there are shapes that have come across, especially the scalloping of the tank and the way the bike sits. A few years later, Bob Trigg has basically said to Norton Villiers Triumph, this isn't working for me, you haven't got any money, and these nice guys at Yamaha want to hire me. So he moved across to Amsterdam as a product planner. And in the very early 80s, Yamaha released the RD350 LC, RD250 LC. And this is the chassis. And this is basically a production version, as far as I'm concerned, of the Rob North chassis. It's the same basic loop design. It's with Yamaha's patented monoshock, although I've never quite got my head around how that can be patented, seeing as Vincent was doing it years before. And on this project, Yamaha had a young man called Masao Furusawa doing the vibration system on the motor. So this bike had a rigid chassis, but a rubber-mounted engine. Furusawa, literally just out of university, working with Bob Trigg on the RD350 LC. Trigg went on to push the twist axis concept and to push the need for a beam chassis very hard. This is the FZ 750. I saw one on display in the museum. It's Yamaha's first proper four-stroke sports bike. The engine's tilted forward at 45 degrees. So this bike is very much conforming to the logic of you put all the weight onto the axis. Trigg also helped with the FJ 11 and 1200s. Same basic concept with the chassis. 10 years later, Yamaha have a nice twin-cylinder engine, and it's not really selling particularly well. So they decided they would build a sports bike. The project leader was a young engineer called Masao Furusawa again, only this time Bob Trigg was working for him. And they put together this bike. It was the first bike to have a deliberately designed cross-plane crank. So it's got a 270-degree crank in it. Within Yamaha Amsterdam, because of Bob Trigg's presence, it was universally called the Norton Commando Mark IV. It's the Commando that didn't exist. But it's that cross-plane crank, it's the beam chassis, it's Yamaha's DNA starting to really come out. After that bike, Furusawa's career went off in a different direction. He got involved in snowmobiles. Chris Vincent with the number 46, which I think is particularly appropriate, on the snowmobiles, and he got his head around suspension to a very great degree here. And then he went across and did ATVs, so he did the YFZ 450. So he was away from motorcycles for nearly 10, 12 years. And if you then look at the rest of the Yamaha range, that's an R1 a few years ago. But again, the engine still leaned forward like the FZ. Obviously, the entire motorcycling world is now using beam chassis, so it's not exactly a Yamaha trademark at all. But that has become Yamaha DNA. You've now got triple sports bikes. Again, 3 cylinders. They picked that up straight after Norton Villiers Triumph went under. And there are other few bits with Yamaha if you look around. I've got a book at home called Whatever Happened to the British Motorcycle Industry. It's written by a guy called Bert Hopwood, who in the 60s and early 70s was the head of engineering at Triumph. And he designed a series of 5, 6 engines that would use one cylinder design as a single, a twin, a triple, a 4, a 5, and a 6. So he had a V6 that ready to go at 1200 cc's. But he built he designed a 500 twin. And if you look at this, it's a twin-cylinder engine with a little dummy piston that comes down, so that when the engine tries to shake, you've got weight going in both directions. So all these ideas and everything else morphed and went through Norton Villiers, Triumph, and have ended up with Yamaha. So if I was to look at the history of the British motorcycle industry, I actually think there's a bit of it still based in Iwata, using some of the same ideas.